Hello and welcome to this lecture on integral calculus. In this video, we see about the double integral in Cartesian coordinates. Let's start with the multiple integral. When we move beyond the single variable calculus, we encounter a function of multiple variables like f of x comma y. To analyze these type of functions with respect to the variable, they have extended the concept of integration, that we call it as multiple integral. And specifically in this chapter we used to study about double integral, which is used to calculate the area and volume under the surfaces. While studying about the double integral, we need a general form. So it can be in the form of double integral over the region R with integrate function f of x comma y, and dA, it denotes the tiny changes in the area with respect to the variable x and y. If the function f of x comma y is equal to 1, then we get the resultant as area. If it is greater than or equal to 0, we get the resultant as volume. I have given some steps to evaluate the double integral, which will be very easier to understand how the evaluation will be done. So first we have to understand the region with the limits of the variable x and y. Next we have to integrate the inner integral with respect to the first variable. Then we have to integrate the resultant with respect to the second variable. For example, just consider a double integral. I'm considering a function xy dx dy. So here this part is said to be an inner integral. First we have to evaluate the inner integral. So then we have to substitute the limits. The next limit will be, the lower limit will be 0. It will be 0 plus any non-zero value will get the same. This part we used to say as outer integral. So first we have to evaluate the inner integral. At last we get the integral with respect to the second variable y. If I evaluate this, we get the resultant. So on this way, we want to study about the Cartesian coordinate. It uses the variable x and y, which is more suitable in rectangular regions. Now the type 1. It is of constant limits. We have categorized the limits in two forms. One as constant, another one as a variable. So if the limits are variable, that belongs to type 2. So here we see about type 1. Just see the given problem. The second integral limits are correspond to x. This first integral limits are correspond to y. So with this, I said before, what we want to do? First, we want to sketch or understand the region. That's enough. Because in that region, we are going to evaluate the given functions with respect to the variable x and y. So first, for example, I may take the limits. The limit of x will be 1 and upper limit will be 2. The limit of y will be 0 and the lower limit is 0, upper limit will be 1. With this, I have to draw a graph. a very simple graph. This is x-axis, this is x-axis, and this will be y-axis. And now we want to draw a graph for x equal to 1. So here I may take a line which is, this will be x equal to 1, and I may take the upper limit x equal to 2 here. I may consider this as 2. So x varies from 1 to 2. Okay, now I'm going for y. So y equal to 0. This will be the same line, no? Y equal to 0, it will be x-axis. And I may take the y equal to 1. I may take here y equal to 1. So this moves from, y moves from 0 to 1. Therefore, this will be the common region. So within this region, we want to evaluate the given function. This is what they are asking for. So simply, what we have to do, first we want to understand the region within the limits of the variable x and y. Next, we will take the problem. First, we will evaluate the inner integral. So how do we solve this? Simply, I may take 0 to 1, and if I integrate this with respect to x, it will be x cube, then x y square, because with respect to x, y remains a constant. Then I may take the limits 1 to 2, then remaining y will be there, and here 0 to 1, and here if I substitute the limits, it will be 8 by 3 plus, we have to substitute the limit 2 for the variable x, so 2y square. So this will be for the upper limit, and if I go for the lower limit, it will be 1 by 3 plus the, here it will be y square. So then we have dy. If I go for the next step, on simplification, 8 by 3 minus 1 by 3, 1 by 3, it will be 7 by 3. Then here we come with y square, then dy. So this is our outer integral. We have to evaluate with respect to the variable y. So then it becomes 1 by 3y plus y cube by 3 with the limits 0 to 1. And what happens on the next step? 7 by 3 for the upper limit plus 1 by 3, we get the result 8 by 3. So this is what the result. So same, we get the result 8 by 3. So just listen, I'm taking the function x square plus y square with the variable dx dy. Here the Differentiation is with respect to dx first, next we go for dy. I'm taking the same similar problem on the next. Here the same function, the limits are also same, but I'm interchanging the dx and dy. You just see the previous problem. Here it is dx dy. I'm taking this on the next problem as dy dx. So the similar way, what will happen if I change the order of integrations? I'm keeping the same function, but I'm changing the order alone. In the place of dx, I'm replacing with dy. Simply, in the place of dy, I'm replaced with dx. So what will happen? Let's see. I'm doing the same procedure. First, I will evaluate the inner integral. I will substitute the limits and I may get the outer integral. With this, I may substitute the I may evaluate this outer integral. After the simplification, I may substitute the limits. I'm getting the same thing, 8 by 3. So, from this, we observe that in the previous problem also, I'm getting the same result 8 by 3. If I'm changing the order of integration, I'm getting the same result again. So, from this, we can make a note that if the limits are constant, if the limits are constant, then the order of integration does not affect the result. So this is a very important note. If the limits are constant, the order of integration doesn't matter. There won't be any change in the answer. Okay. So on the next, a similar problem. This is the problem. Here some other functions x, y, x plus y. First, I may simplify the given function x, y, the x plus y. And I'm just multiplying x, y into the term. And the same, the remaining are same. What I will do first, I will take for the inner integral. So I will integrate this function with respect to y. Here, with respect to y, x square remains constant, so x square is there. If I integrate y, I will get y square by 2. Here, x will be a constant, y square means y cube by 3. Then I am substituting the limits 0 to 2. Once if I substitute the limit, what happens? I may get 2x square plus 8 by 3x. I'm substituting the upper limit because the lower limit is 0. No, the 0 plus non-zero value, we will get the non-zero value. So this will be the outer integral. So if I integrate this with respect to x, here it will be of x square. No? 2 will be a constant x square with respect to x. Then it becomes x cube by 3 and 8 by 3x. If I integrate x, it will be of x square by 3 and we can cancel by the value. And the next, at last, we get the answer as 30. Next, we see about type 2, a variable limits. That means limits will consist of variables. You just see the y, the limits varies from 0 to x. So the limit of y will be 0 to x. So y depends on x. Anyway, it is a variable. If you see the variable x, it varies from 0 to 1. Of course, it is a constant, but here y varies with respect to x. So the limit of y which has a variable x. So that we call it as type 2 limit as a variable. So one more thing, in this type 2 you have to be very careful. If they have given any problem, the same, I may take a same problem 0 to x, y, dei, dx, dy. Just see that x has a limit from 0 to x. How it is possible? If such cases arises, then definitely this problem is wrong. So the variable can't have a same variable as a limit. As same, I may give one more example 0 to 1, 0 to x square. I may take here as y. Okay, so I may take a same function. Here it will be dy. dx. Now you just see this y varies from 0 to x square. It is okay. X varies from 0 to y. It is also done. So this is this can be done, but the same variable can't have a same thing as a limit. So this is wrong. This is right. So on the next, we will do the same thing. What we will do first, we will evaluate the first inner integral, and we already know that integral y dy it will be of y square by 2, and then we will substitute the limit x. Then what you will get here, x square by 2, the same thing, x square by 2. This will be a outer integral. We may take 1 by 2 as a constant. Then we will evaluate this 1 by 2 x cube by 3 as 0 to 1. We make it 1 by 6 as the answer. So the next problem here, the limit of y depends on x. So it varies from x to root x. So clearly that y is depends on x, and dx varies with the constant limits. The lower limit will be 0, the upper limit will be 1. Surely this problem will be in the correct form, so we may evaluate this. So first I am making a simplification of the given function. It becomes x square y plus x y square, and next I am making a first integral, and I am making a integration of this function with respect to y. So with respect to y, this x square it will be a constant, and I am integrating y, it becomes y square by 2, and again x will remain constant, and y square becomes y cube by 3, and I may substitute the limits instead of y. So it becomes 0 to 1 x square, and a square root of x, it will be simply x by 2 plus x into root x power 3 by 3, and minus x square into x square by 2 plus x into x cube by 3, so over dx. So simply if you consider this, it will be of x cube by 2, and here it becomes 1 by 2 plus n 1 by 2 into 3, 3 by 2 plus 1, so it becomes 5 by 2 by 3 minus x power 4 by 2 plus x power 4 by 3. So on the next I am getting the same, so I am making the simplification over x power 3, x power 4, 5 by 2, 4 over the simplified form, and still we may make a simplified like this, and then we may substitute the limits with the 0 and 1, and I am getting the simplified answer at last as 5 3 by 56.